All right, so here what we have is the table here shows the cost of purchasing different combinations of hamburgers, fries, and soft drinks, and they give us, they purchased, one hamburger, three fries, four soft drinks. It was $11, and one hamburger, five fries, six soft drinks was 16. No hamburgers, three fries, two soft drinks, and that was six. So what we're going to do is we're going to let X equal the hamburgers, Y equal the fries, and Z the cost of the soft drinks. And now we're supposed to write a system of three linear equations that represents this data. All right, so we already got X, Y, and Z as far as they are as defined. So now we're just going to say, well, that's going to be X, that's X, this is Y, this is Y, this is Y, this is Z, this is Z, this is Z, and then we have equals, equals, equals. And so now we can just write it straight off of there. We don't even have to look at anything. So we have X plus 3Y plus 4Z equals 11. We have X plus 5Y plus 6Z equals 16. And then we have 0x, but we have 3y plus 2z equals 6. So now we've got our three equations with three unknowns. So this is our first one, that's our second one, and that's our third one. All right. Um, I think because we have only y and z in this one, let's get rid of x between these two. So what I'm going to say is let's take maybe 1 minus 2. So we have x plus 3y plus 4z equals 11. Now we're going to take the opposite of this one. So it's going to be a minus x minus 5y minus 6z equals a minus 16. And what happens is, again, we wanted the x's to cancel, so they canceled, so that's good. Now we have 3 minus 5, so it's going to be minus 2y. And then we have 4 minus 6, so it's going to be minus 2z. And 11 minus 16 is going to be a minus 5. Okay? And what I'm going to say is, let's call again that a. Now I have an equation with y and z, and I have an equation here with y and z. So let's take, basically, if we look at these, we have a 2z and a minus 2z. So if we just take a plus 3, that should get rid of our z's, and we're left with y's. So minus 2y minus 2z equals a minus 5 for a, and then plus 3y plus 2z equals 6 for the 3. So again, we do this to do specific things like get rid of the z's. So that's what happened here. Now we have a minus 2y plus 3y, so it's just going to be y. 6 minus 5 is 1. So now we've got y. Well, now what we can do is we can either plug y equals 1 back into a or into 3. It really doesn't matter. Because this one has negatives, let's do the positives. So now we're going to substitute. We're going to say 3 times 1 plus 2z equals 6. We plugged it back into 3. And now we have 3 here, so subtract 3. Oops, that's a big minus, but whatever. And so we have 2z equals 3 divided by 2, z equals, well, if we put this in decimal form, because we remember that these are prices and usually don't represent a price as a fraction, so it's going to be 1.5. We could leave it as 3 halves, and that's fine as well, but so that's going to be our z. Now, what we can do is we can plug this back into either 1 or 2 and solve for x. So if we plug it into, say, 1, then we have x plus 3 times y, which we said was 1, plus 4 times. Now here, it actually might be better to have the half because we can cancel then. So 3 halves, that 2 will go in here, and that'll make that a little easier, I think. And that's equal to 11. So here, like I said, I'm going to say, well, since I'm doing this by hand, that 2 goes in here once, that goes in here twice. So now I can take easily 3, and then 2 times 3 is 6. So 6 plus 3 is 9. So I'm going to subtract 9, and I get x equals what? 2. So I'm saying then that now we have to solve and interpret. So let's go ahead and solve and interpret. So what we have is x is going to be equal to $2 per hamburger. Y is equal to, that's 1. So it's going to be $1 per fry. And Z is equal to, now when we go back to the decimal form, that's $1.50 per drink. Okay, so that is what I'm saying is the answer. And that's kind of interpreting the answer. You know, it's $2 per hamburger, $1.50 per set of per pack of fries, and $1.50 per drink. Now I have to check these. So what I'm going to do is I think I'm going to have to use the next page. And so hopefully I have all this written down so I can do it. So we have the x is going to be, I'm doing the equation 1 first. So I'm going to have a 2 plus a 3 times 1, and then plus, and then I have 4 times, and I'm going to put that fraction back in to make it easier, like I said. So we have 2 plus 3 is 5. That goes in here 2. 5 plus 6 is 11, so that works. 2. All right, so here we have 2 plus 5 times 1 plus, and now it was 6 times, again, 3 halves is easier than 1.5, and I think that was 16. So here we have 7, the 2 will go in here once, it'll go in here 3, so we have 9, 10, 11, 16, so that works. And 3. We have just the y's and z's. So now we have 3 times 1 plus 2 times 3 halves. Again, using the fraction is easier. So that cancels that. We have 3 plus 3 is 6. So that works. So that means that this really is the solution to this problem and the system of equations that we wrote from that problem. All right, let's stop there and we'll come back for some more.